This conference will now be recorded.
Let's get started. So we have a lot of things to cover. Um let's see. Okay. So we'll start off with Kubernetes today. So yesterday we talked about Docker and how to deploy Docker container, how to deploy application, how to create our own images, push it to the repository and write Docker files. We saw about Docker Compose, how to create multiple containers, and we saw about Docker Swarm, how to orchestrate. So the Kubernetes is a orchestration tool, which is being widely used by the industry. It is gaining more popularity because Google is backing this up. So this was actually founded by Google and it is given to the community as a community project. And they are still supporting Kubernetes. And now the Kubernetes administrator and other certifications are gaining more popularity in DevOps world. Okay, so there are a lot of things on Kubernetes. We will not be able to cover everything, but at least I can introduce you to what is Kubernetes, how you need to work on that, how to install the clusters, different ways of installing clusters. We will try to install one cluster with EC2 with one master and two nodes, right? So there are multiple ways to create our clusters and then work on your Kubernetes. Okay. So Kubernetes, sometimes they call it as K8s because there are 8 characters between K and the last 8, right? So it's called K8s. So Kubernetes is a container management technology developed in Google Lab to manage containerized application in different kinds of environments, such as it can be physical. You can have Kubernetes on physical, virtual, or any kind of cloud infrastructure. It's an open source system which helps in creating and managing containerization of your application. It's basically an orchestration tool. Kubernetes, also known as K8s, was built by Google based on their experience running containers in production. Now they made it as an open source and is arguably one of the most popular container orchestration technologies that we have in the industry. To understand Kubernetes, we need to know two things. One is for container and another is for orchestration. So container, we are aware that the images are built as a containers and containers will be used, and the orchestration is just a strategy how you wanted to place your containers. So some of the features of Kubernetes: continuous development by integration and deployment. Containerized infrastructure, you'll have only containers running in Kubernetes. You cannot put normal applications there. Application centric management, and you also have an auto scalable infrastructure where you can go and do the auto scaling just like what we saw yesterday, right? You can scale them. Environment consistency across development, testing, and production. If you have one environment, then you will have the same results will be available across all the environments. They are loosely coupled infrastructure where the components can act as a separate unit. So that means this is more suitable for microservices architecture rather than the monolithic application. So microservices architecture is an architecture where all the modules are loosely coupled and each and every module runs as a separate application. Say for example, there is an e-commerce site. So you have payment as separate application, login as separate application, all small applications which are loosely coupled and they have some kind of dependency, but not the completely um, tightly coupled, right? They're all loosely coupled. Higher density of resource utilization, so it will try to maximum utilize the resources that are available with you, and you can predict the infrastructure which is going to get created with Kubernetes, right? These are all configuration based and YAML file based, so you just need to understand this. That's all. So the very key important when you sit for your interview for Kubernetes is the Kubernetes architecture. Kubernetes follows the client server architecture similar to our Docker, where we have master installed in one machine and nodes on separate Linux machines, right? So there are some components which are specifically there only on master. There are some components which are there specifically on nodes. So we need to know what are those things and how this is laid out actually. So some of the master components, first component called HCD. Okay, HCD. HCD is nothing but it's a database. It's a key distributed key value database which stores all the information about your cluster, about your Kubernetes cluster. Okay, so anything that you query, basically the data is returned from this database only. So it stores the configuration information which can be used by each nodes of the cluster. It is highly available key value store that can be distributed among multiple nodes. It is accessible only by Kubernetes API. We will not be able to access directly. Okay, as it may have some sensitive information. It's a distributed key value store which is accessible to all the components within the master. So HCD is one of the thing. Then you have API server. Kubernetes is an API server which provides all operations on cluster using the API. So whenever you call any Kubernetes command, it basically talks to the API server, and the API server will in turn talk to the other components and get you the results back. So API server implementation implements an interface, which means different tools and libraries can communicate with it. kubeconfig is a package along with the server-side tools that can be used for communication. We will see that how to do that. It exposes all this Kubernetes API server will expose all the Kubernetes API. There are thousands and thousands of APIs. Then we have controller manager. So this component is responsible for most of the collectors and regulates the state of the cluster and performs a task, right? So it will always maintain the state of the cluster. Suppose you say you always need a 2 node, then it will make sure the 2 node is always available. Even if 1 node goes down, it will try to bring it up to the desired state, right? So the controller manager does all the heavy lifting for you. So it can be considered as a daemon, which is running in a non-terminating loop and is responsible for collecting and sending information to the API server. So the controller server will send it to the API server, all the information, whether the current state of the cluster is maintained or not, and all those things. So it works towards getting your shared state of the cluster and make changes to bring to the desired state. So some of the key controllers that we have for controller manager is replication controller, endpoint controller, namespace controller, service account controller, deployment controller. So everything is a controller there. So for each and every API, there is a controller and it works on that controller. The controller manager runs different kinds of controllers to handle nodes, endpoints, and all the things that happens in the Kubernetes is happening through your controller manager. And then if you are installing Kubernetes on a public cloud, then you will get an additional cloud controller manager. This cloud controller manager will be responsible for talking to the cloud specific APIs, where your controller manager from Kubernetes will not talk directly to the cloud. So there is an interface between your cloud and your Kubernetes master, and this cloud control manager will talk to all the cloud APIs. Okay, it will talk to all the cloud controllers. This component will come only if you install it in cloud. If you don't install it in cloud, you want to install it in on-prem, you will not get this cloud control manager. So that time that your controller manager will take care of everything. Only you will get additional cloud control manager if you are installing your Kubernetes cluster in a public cloud like Azure, Google, or AWS, right? Scheduler, there is another component called scheduler. It's one of the key component in the Kubernetes master. It is a service and master responsible for distributing the workload, right? So it will distribute the workload to the nodes. It will make sure that which node is what access. It knows where to go and put our application into and all those things. It is responsible for tracking the utilization of workload on each cluster node and then placing the workload on resources which are available and which are ready to accept the workload. So this scheduler is very important. This is what it will take and put the application. In other words, this is the mechanism responsible for allocating pods to available nodes. So we will see what is a pod. So pod is a smallest unit that can run in Kubernetes. Inside the pod only the container will be running. You remember yesterday we created a container and we did talk to the container directly. Here we cannot talk to the container directly. The container is encapsulated into pod. The way you can only talk to a pod, right? You cannot directly talk to a container in Kubernetes. The scheduler is responsible for workload utilization and allocating pod to a new node and all those things, right? So these are some of the components you must keep in mind for your interview when you go. The Kubernetes master has all these components. Similarly, then the node components. What are the things that needs to be node? Docker. The first requirement of each node is Docker, which is a runtime environment for your application, right? So we are running everything in Docker, and they are going to remove the dependency on Docker, and it's going to the Kubernetes is going to start using Docker D instead of Docker Docker as such, right? So that's going to happen quickly. But anyway, still the Docker engine is used to run all your containers. So there is a service called kubelet service. This has to run in each and every node, which is responsible for relaying information to and fro from the control plane service, right? So this guy will make sure he will send information about the node, and he will receive everything happens through this kubelet service. So if you see here, this kubelet service is the one which will be available in all the nodes, and this will help to relay all the information about the cluster, what is happening inside the cluster, and everything. It will reply back to the control manager. Okay, then it interacts with HCD store to read configuration details, and it can write values as well, right? So it will interact with the database. This communicates with the master component to receive command and work. So this is the where your works gets distributed from the scheduler to the node via your kubelet service. The kubelet process then assumes responsibility for maintaining the state of the work and the node server. It manages network rules, port forwarding, everything is taken care by your kubelet. So if this service is not running, then your node will not be given any work. Then there is a Kubernetes proxy service, or it's called kube proxy. So this service is responsible for all networking related information within the Kubernetes cluster. So proxy service, which will run on each node, helps. It will make sure that the services are exposable and it can be accessed by the external host. It helps in forwarding the request to correct containers and is capable of performing primitive load balancing. Okay, so you can do all the primitive load balancing as well. It makes sure that the networking environment is predictable and accessible at the same time. They are all isolated as well. So Kubernetes proxy is the one which will manage all the nodes, volume, secrets, and all the other controllers that actually need for your node component. So these are the basic components you need to know. So when you go for an interview, there will be some questions on what are the key components of the Kubernetes master and Kubernetes node. So we have Kube API server will expose the API, HCD with a distributed key value accessible to all. Controller manager, it will manage multiple controllers to handle the nodes, and scheduler will make sure it is the one which will allocate all your applications to the distribute the workload. Additional, you will get a cloud controller manager if you are going to install your Kubernetes cluster on a cloud, right? That's what we are going to do. And in the Kubernetes node, we have kubelet service running in all the nodes, and then kube proxy will be running. Apart from that, the Docker engine will also be running. Without Docker engine, you will not be able to deploy your container there. Okay, so these are all the few components that you need to keep in mind. And the important difference between Docker Swarm and Kubernetes is the Docker Swarm, the master also will take the work and do it, but whereas in Kubernetes, only the nodes will, all the task will be performed by nodes. Only the master will throw the commands. It will only order the nodes to do. Master will not do the or run any job or any pod or any container. Okay, for that matter. So what are the different ways that we can install Kubernetes? There are multiple ways to install Kubernetes. Okay, for the local installation, if you want, you can try with Minikube. Okay, Minikube is a single node cluster. Minikube is a single node cluster which you can set up in your this one locally, but only make sure the Docker needs to be running if you are installing Minikube. Minikube is also a Docker image, so and you will see the Minikube will install as a Docker image. The only thing that you need to keep in mind, this Minikube will have only one single machine, so that will act as both master and node. Okay, so if you want, you can do that, and there are multiple ways that we can go ahead and install production grade like Kubernetes, which is what we are going to see. Okay, let's go and see how, what are the different ways. There are so many ways that you can set up your Kubernetes. I will share all this information to you, but we will do only one which we can do. I don't think we have much time to do everything, right? So we are going to use our kops. Kops is nothing but Kubernetes operation. So we are going to use kops and we are going to do this. Okay, so how are we going to do this? These are all the steps that we are going to follow to do our Kubernetes cluster. So what we are going to do, we are going to create one EC2 machine that's called a bootstrapping EC2 machine, and then we are going to install a AWS CLI. We are going to install kubectl. kubectl, they call it as kubectl or kubectl. Kubectl or kubectl is a kind of a client which can interact with the Kubernetes cluster. Through this commands only we will be running, like say kubectl create, kubectl get, right? All those things. Then once that is done, then we will go ahead and install kops. Kops is Kubernetes operations. With the help of kops, we will be able to create our cluster. Okay, that's what we are going to see. This cluster creation will take some time. So let's first go and start creating our cluster and let it come up, right? So I'll show you how to create one cluster. Then I will share you all the details for the other ways to create cluster, and you can do that. Okay, whenever you have some time, please go ahead and do that. Okay, so since we need multiple machine, I'm just going into AWS. And it's not only AWS, you can also do it on the on-prem also, right? So one of the way that you can do is using kubeadm setup, right? This kubeadm setup is where you can go and set up in your on-premise service, right? All the complete steps are given there. And I've also given you how to test that cluster as well. So you can go ahead and do this, or you can do it in your virtual machine as well. And you can also use the AWS EKS, that is your Elastic Kubernetes service, and you can install that and you can do as well. And you also have something called kind. Kind means Kubernetes in Docker. So Kubernetes itself is available as a Docker image. So you can use that to go ahead and do that, right? So you can go and see how to create this, and you can use that also as your um, Kubernetes setup. And then we are going to see kops, and there is something called kubespray. Okay, kubespray is one of the abstract layer that you have. You can go and use a kubespray. Kubespray uses Ansible. Okay, kubespray uses Ansible YAML files to install all your master and nodes, right? Again, I've given some comments there. For me, it took like more than 2 hours to bring up this cluster. So please make sure you are doing it very carefully. Okay. Then this is the Minikube setup, which you can do in your local. I've given how to do that and start that and do that. In my machine, if I start Minikube, everything else will stop. Okay, everything else will stop. So that's why I'm not doing that. We will directly get into our cluster creation here. Okay, so many things that we need to do. So what we are going to do, we are going to create one instance. Okay, the kops, the command kops itself will create multiple instances for us, like master and node, but this is a bootstrapping instance. From here only we will be running everything, right? We need one machine to start with. So what I'm doing, I'm just keeping all these things as default. Okay, just make sure you have a key pair so you are able to log into that system. And very important, make sure you have a security group which allows all access, so that you don't have to keep on going back and adding different ports, right? So let's go and launch this instance first. And let's go to our MOBA Xterm here and get this up running first. Then we will start executing those commands. So the default username is EC2-user. Keep that. An advanced setting, make sure you select your private key, whatever that you have given. Make sure you have access to that, and go to the terminal settings and change your color of your terminal so that you will know that it's easy to go spot all those things, right? You can run all these things as a script also if you are really aware of this, or you can do this. Okay, so let's go and clear this and do a First command will update the current AMA with the latest patches, right? Whatever that we have taken. So there are these many packages that it needs to get updated, like 53 packages. Let it go and do that. Once that is done, then we'll have to install unzip. Unzip might be there, but let's install if it is not there, right? Okay, unzip is already there. It says already installed, so nothing to do. Next thing we need to install this AWS CLI because it uses some command line parameters also, right? So make sure you select your. So what we are trying to say here, download this package and output as AWS CLI version 2.zip. And using the unzip, please go ahead and unzip that guy, right? You will be able to see it here. You can see the unzip this. Once you unzip, please go ahead and use this step to install your CLI. Okay. Once you install, just go ahead and say hyphen version. And you need to get your CLI version like this. So your CLI is installed correctly. Okay. Next thing is we need to install the kubectl. Kubectl is a client interface that you need, right? So go ahead and curl this. When you curl this, you will get this and you will get this, and then we are moving it to swap. Okay. If you do this, you will see a kubectl there. Okay. And go ahead and since it's a executable, give a execute permission for this. You will get an execute permission, and now move this kubectl into user local bin so that it is moved to the path and we can run kubectl from anywhere that we want. Otherwise the problem is you will need to kind of only run in that particular folder. So set it up in the path. Don't do it in your local windows, all these things. This will take your entire resource out. You will not be able to do anything. If it is all installed correctly, go and check for the version. You should be able to see that it is installed. See, it's already installed, but the connection is not yet done because we don't have any cluster now. Okay, but it is installed. Okay, you can see all the versions and everything there. Okay, this is on the kubectl. Once the kubectl is over, now you need to create an IAM user role with Route 53, all this full access, or just create one role with administrator access. Okay, so to create a role in this one, go to a service called IAM, which is Identity and Access Management. Go and right click there and create a role. If you already have a role, that's fine. Otherwise, create a role, and that role will have an admin access. That's all. And that will be used by your EC2. So just go to role and go and create a role, and that will be used by our EC2 machine. We have to attach this role to the EC2 machine so it has access to all the resources. Do next. And what is that you want to do? You want to put the administrator access. Okay, put the administrator permission so it has all access to all the resources. Do next and give a name of the role. Just call it as K8 admin role. K8 admin role. Create a role. Okay, it's creating the role. Once the role is created, okay, once the role is created, you can go and view the role, and you can see you can have this permission, and it is trusted or it will be assumed by EC2. So go back to the EC2, go to the actions, go to security, modify IAM role, and select the role that we have put it here, right? So K8 admin role, and update this IAM role. So this is done. Once we are done here, we will have to do the installing kops. So similarly, install kops. Okay, we'll install all the kops, and you can also give the execute permission to this. Okay, you will get as kops Linux AMD 64. So what we are doing, move kops Linux AMD 64 to user local bin as kops. So it is easy for us to just say kops instead of giving every time kops Linux AMD 64. Paste it there. That's fine. The next step that we need to do is like you need to create a Route 53. If you already have a public zone, you can have it as a public zone if you have a domain. Otherwise, you can go and create some private hosted zone. It's up to you. So I have a public zone. I will be using the public zone. Okay, and this public zone. Then we'll have to create a bucket because all the configuration will be stored in the bucket. So this is my bucket name. Since we have already configured our AWS CLI, we should be able to make the create the bucket from command line itself. So just to make sure the bucket is created, you can go back to S3 and check. So guys, always keep in mind, DevOps along with cloud will have more power because they'll be using cloud along with DevOps. Okay. So this is the one that we just created now. Then let's go and export this kops state store where all the state will be stored. It will be there in this bucket. And let's go and set up this path. So to set up the path, it should be export. If you want to keep this permanently, put it in your bash RC profile. Bash profile, right? You can put it in RC profile, and you can, whenever you log in, it will automatically get loaded. But since we are just going to do once and we will be deleting this cluster, just go ahead and do it on the runtime. Once that is done, the next step is to create a key. Just create an SSH key and say SSH key gen. You will generate a key. It will ask you want to put it in this place. Yes, it will put it in the folder called .ssh. Okay. Next, it will ask, do you want to give any paraphrase or any password? Just leave it empty and everything is saved. So if you go and see, you can go and see it in this place, right? ls-la. You will see a .ssh folder there, and all your keys are here. Sorry. All your keys are here. Okay. So once that is done, now our only work is to go and create this cluster. So before we create the cluster, go to this readme file, and you can see different options what are all available. I have just taken only the minimum that is needed for us, but there are a lot more things that you can go and see here. So many parameters and options you have, which you can pass while you are creating your cluster. So what we are going to do, we are going to use this. So we are going to say kops create cluster is the command. The cloud that I'm going to use is AWS. What are the availability zones I'm going to use? I'm going to use US East 1A, 1B, and 1C. And name of my cluster will be devk8 chandradc.org. My DNS zone name is chandradc.org. My node count, I will have 5 nodes. And then one master size is t2.medium and node size is t2.micro. Master image will be this one and the node image will be the same, right? So with all these parameters, so these are all the parameters values that I am giving. Say for example, when I say DNS, right? See here, DNS, public, private, none, right? You can use all those things, right? So you can put DNS hosted zones. Then you can give a which cloud, right? Which cloud that you wanted to use. See here, cloud, whether it is AWS, GCE, DigitalOcean, OpenStack, right? Like this, you can give all those things. And then you can give what is the image. Then you can give a node count, right? Node count, how many nodes you want, how many masters you need, right? Master also can give multiple masters. Okay. So now let's take this guy, go here and paste it here. Okay, what this will do, this will start first creating a configuration. Okay, it's all created now, but it's still not yet started. Okay, so just go back to your, see here, it has already created all your configuration files. From this is where it will take all those details from here. That's why we need this S3 bucket. Now to actually configure, you need to run kops update cluster. Okay, and give yes. When you give yes, it will start actually creating. Okay, now this will take at least 10 minutes. Okay, it will at least take 10 minutes. Okay, it should be ready in few minutes, they say, but basically it is going to take a lot of time, at least 10 minutes, right? Minimum 10 minutes. Let this be there. We'll come back and check. So that is where our this one is over. We just need to make sure we export this kube config and then start validating after 10 minutes, 10 to 15 minutes. It again depends, right? Then we can start testing our node. Okay, let this be there. We'll come back. So this is some of the installation that you can go ahead and see. And we have some links to the cheat sheet of your kubectl as well, or kubectl. Whether you call it as kubectl or kubectl, both are same. If you try to watch some videos, they may say kubectl, so don't get confused. This is what is there having kubectl. So kubectl, you have all the cheat sheets, all different uh, what to say, different commands that you have for your kubectl. Okay, I will be sharing this deck so you can use all your this one. Just like our Docker container, everything is the same command, right? It's all same command. But there are a lot more features here, so you can go and check all your this one. Kubernetes.io is the official site for your Kubernetes. Okay. So let this come up. We will talk about what is a pod. A pod is a collection of containers and its storage inside. Its storage is inside a node of a Kubernetes cluster. It is actually stored inside. So a pod is nothing but you have a container. A pod, the recommendation is always to have one container per pod. Okay, one container per pod. Don't make it more heavy. Don't stuff one pod with multiple containers. If there are any dependent containers, right, you have container and you have a helper container, then that case you can have more than one, but it is always recommended to have one separate container for one pod, right? So have it as a lightweight. It is, you can create pods with multiple containers also, you can create, but it's not advisable to do that. In case if you're having some front end and back end, you can go ahead and do that, right? So there are two types of pods: single container pod and multi-container pod. A pod is nothing but, think of it as an abstraction, encapsulation, right? Encapsulation around your container. So directly you cannot talk to the container. You need to always talk through the pod. Whereas in Docker, you can directly talk to the container. That's the difference. So that can be they can simply be created with kubectl run command, and where you have defined your image or the Docker registry, which will pull while creating the pod. So it will again take the all the images, everything from registry, because ultimately Kubernetes is not going to do anything except orchestrating, right? Though your application will still use the Docker engine and it will perform all the Docker related commands. So it will say kubectl run, give the name of the pod and image name from the registry, for example nginx, right? So we will create a pod like this. You can say tomcat or kubectl run tomcat and image is equal to tomcat colon 8.0. It will download the 8.0, create a pod and deploy it. So this same thing in a single line can be written as a YAML file like this. Okay, you can write it as a YAML file, and these are all the keywords that needs to be there in the YAML file. API version, kind, what is the kind of this deployment? It's a pod. Then it's a metadata, data about your this one, and you have to give a specification. So you have to, under specification, you have to say the container and what is the name of the image that you want, container runs in which port, all those things you can give here. So this is a front end, this is a back end for MongoDB. Once you have done that, you can just run kubectl create -f tomcat.yaml. You can save this as a YAML file and run it. It will create both Tomcat and database for you. Okay, so there is a difference here, run and create or create and apply. There is another command called create and apply. When you apply if there are any updates to the YAML file, it will apply. If you use kubectl apply, if you use kubectl create, it will create from scratch. Okay, we will just see. Just say cops validate cluster. Okay, still not authorized. That means still that error is there. Just hold on for a minute, right? You will sometimes, if you get this error, the recommendation is to export this kube config and wait for some more time, right? Export, then the context will be set to our pod, and just go and validate the cluster. It's validating the cluster. See, actually our cluster is ready now with one master and 5 nodes. See here, with one master and 5 nodes. Let's go back here and check. Go and refresh here. You can see here, I have 1, 2, 3, 4, 5 nodes and one master. 5 nodes and one master, all created with T2 micro, and the master nodes with T2 medium. That is what we have given. One thing you need to keep in mind, I have to make a note there, that go to this nodes or go to the security groups. Just a minute. Click on this node, go to security group, right click on this security group, open in a new link. Okay, and add one rule which will allow all the traffic, all the port. The reason for that is it will be specifically given for everything, right? So it only allows from certain this one, it doesn't allow from everywhere. So make that to allow from everywhere so that we don't run into any issue, because when you do some networking and everything, there will be different ports dynamically added, which you need to go back and add again. So it's just better to add, say, all traffic and make it custom from everywhere. So make it for both master and for nodes. So if you are aware of AWS, you should be knowing this. If you are not aware, you may be reading this when you're learning AWS. Okay, now this one is ready. Now let's go and see how to test our cluster. So this is the way that how you create your production grade cluster. This is a normal production grade cluster that we create. Of course, we went all for small machines because we are simply just doing some sample. But in your organization, the machine type might be more, right? And see, we went to 1A and 1B and 1C. We asked it to create in 3 availability zones. It has created that. Okay, let's go and test this one. So run this command, kubectl get nodes. You should be able to get all the nodes. See, these are the nodes. This is a control plane. That is what is the master actually. And these are all the nodes that is running, right? Nodes that are running. So let's go and we will create a client called deployment. It's called my nginx. Name of the deployment is my nginx, and my image name is nginx. And I need replicas. How many replicas? I need 4 replicas. Okay, you can go and create how many replicas you need. It's up to you. Okay, we already have 5. Let's make it 6. Okay, your deployment has been created. To check the deployment, go and say kubectl get deployments. So this is the deployment, right? This is the deployment. So you can go and say kubectl describe deployment my nginx. It will show you what has happened, right? See, it is scaled up to replica max to 6, right? 6 of 6 replica created. and you can see all the details here, what it has done, right? So this is what this one will do. And also this has done as a pod. Let's go and check whether it has created the pods, nginx pods, right? Pods are nothing but the one where our containers are running. See, there are 6 pods all running with my nginx, right? They're all running. Okay. Now, how do we go and expose this to outside world, right? So there is when you do an expose, it will create a service for you, and you can go and check this. And since we are using AWS, we're going to use load balancer. So this will automatically be load balanced on port 80. Okay, let's go and say kubectl get. You can put get service or get svc, right? That also will work, right? Because my nginx is your external IP is pending because that load balancer is getting created. It will take some time for you to create. So once this is available, then you should be able to go and browse and check, right? And you can also say paste this to say hyphen output wide. Wide means it will show more fields, like what is the port selector, so many things. It will give you additional fields that are there. Okay, so we need to wait. Since we are doing a load balancer, we just need to wait for this. Okay, so to check that, just go back to your load balancer. See, it has already is creating the load balancer. And if you go to the target groups, it's a classic load balancer. So it has already put all our machines here. Slowly it will add 2 more machines inside, and you will see all the nodes here. Okay, so you have to just hold on for a minute. It will take some time to create this and bring it in the active state. Once it is active, then we should be able to access this using this DNS name a record, right? So that is what we are going to see, how to access our this one. Okay, let's see one thing. kubectl get pod, all these pods are running, so you can go and describe one of the pod to see what has happened actually. ctl describe pod, and take one of the pod here and do a paste. Click here, see what it has done. It has started the container nginx, it's created the container, it's tried to pull the image, and then it created the container and it started the container. So you can see all the things here. Everything should be true here. Type is status initialize is true, ready is true, container ready is true, and pod is scheduled as also true, right? This is what we will see. All the related container D, your image ID and everything will be here now. Okay, now you can go and try Docker images. There is no Docker here. Go to the master, it should be there. Okay, it's fine. See, this is already created. So just copy this entire stuff. Okay, copy, go to the browser and paste this classic load balancer DNS name, and let's see what happens, right? See here, you get your nginx. Now, whether it is coming from this particular machine or that particular machine, that it's all the same nginx, so it is actually doing a round robin. Okay, so you can go in and check. Okay, that's fine. Now let's do one more thing. Sorry, not Docker. kubectl get pods. Okay, now we have created a deployment, right? So if you go and see, we have created a deployment. kubectl get deployment. We have created a deployment. If you go and do kubectl describe deployment by Nginx, right? You can see here, it has put, it should be desired six pods we asked it to create. So 6 are desired, 6 updated, 6 in total 6 are available. Now what will happen if I go on remove one, right? Let's go and see. So we say kubectl get pods. I have this one running. Let's take the first one, 62JJN, right? I'm just taking that. I'm going to say kubectl delete pod, this specific pod, right? Okay, this pod is deleted. Now go ahead again check. You will see there is another one created already for you. I think it's something is 1, 2, 3, 4, 5, 6. It's just 6 seconds. This one, WGFDS, is the new one. See, so it will always try to maintain the state. How this is happening? As I told you, your kubelet service that is running in your node will relay the information back saying, hey, one of my pod is gone. And then what that scheduler will do, it will go to the API controller. Controller will say, hey, already this guy need to have a 6 pod, but only 5 is running. Those scheduler will bring up another pod. That's what has happened now. Okay, so this is how this one happens. Okay, so you can keep on doing, and you also have access. You can access this container also directly. That you have to use your copy this and say kubectl same command what we did, right? Execute -it bash. See, we are already inside this container. So if you go to this container, you have the normal stuff that whatever we have, right? So you can go to cd where, sorry, user share, that's called user share nginx, then html. Go here, you will have the index.html is what we are seeing now. So you can also do something like you can put something there to see if you are able to see that, right? You're not supposed to do this, okay? You are not supposed to do this. Okay, you keep hitting your load balancer. So when that traffic goes to that particular machine, you may be able to see number text there, whatever that you have made the change. Okay. So again, this is all round robin strategy. So you need to wait. Okay. So this way you should be able to go ahead and see whether it's going right. So be careful. You will be having your lot of cache in the browser. So use different browsers to see if you are able to see that, right? So you should be able to see at some point of time when it gets into this. So if you go to a cat index.html, see it's putting everything underneath. We have put test. Okay, so this is how you can log in and log into the this one directly. Go to this kubectl this one, and you can see all the commands that we are doing are from here only, right? You can go and see all the, you can go and get the context, what context, current context we are in, right? So you can get the current context. It will display the list of all the contexts that are there. You can go and try all those things, right? This is the current context is always star. We have only one, and it is we are on that only, right? So you can go and do that. And you want to, if you're having multiple, you can go and change it to a specific one, and all those things that you can do. Okay, so kubectl, if you create a YAML file, you can use apply, and you can go ahead and create this also. Let's go and see how to do that, right? So let's go and see how to create some pods using don't try to create anything in the I'm also have some more this one which I've done for separate Kubernetes course. I will try to share that with you guys, and you guys can use that as well. Okay. Okay, we have a we have an Nginx. Again, it's an Nginx deployment, and we have replicas too, and we can run this in the our as a YAML file. So let's copy this and go and say nginx underscore pod dot YAML file and go and do a paste here. This is what you will be seeing. The API version is always apps version 1. You can go and find out the kind. The kind is deployment, or it can be pod, it can be deployment, it can be anything. These are all that nothing but your controllers there, right? Then the name of the deployment. Then we are giving some labels for this, how to select, and then template inside the template, metadata. Then we have spec specification. Under that you have containers. Under that we have name and image, what we want to do and what are the port that we need to kind of actually run this, right? So these are the things that you can go ahead and do it. And to do this, you need to do a kubectl apply, or you can do apply or create also, right? You can do create, and you have to give first the file name here. See, your deployment has been created. So just go and see if your deployment is created. Kubectl get deployment. You have two deployments. One is my nginx, which is already having 6 pods, and you have this one with another pod. So if you go and say kubectl get pods, see all the 2 pods here, and these are all the 6 pods that we were trying to run previously, right? So this is the way that you can start using your this one, right? So you can use a single container like this, or you can use a multi-container also like this. And there are some more parameters that you can keep using. One is that you have something called Kubernetes job. You can create a Kubernetes job and run it as an ad hoc command, just like a cron job. You can run it as an ad hoc command. Okay. So this is a job. So you can simply go and create a job, and this job will just run a Python program, and it will just go and print success. That's all, nothing else, right? So this is what you can do. And you can go to jobs and check the status. That will show you what are the jobs are running. So let's see if we can take this and run one job and see if we are able to run, right? Can be any name you want, it's up to you. You make sure the indentations are right and clear, right? So that's the only thing that you need to keep in mind. So if you see a container name is this one, so this should be against the name, and this is a command, and there's a restart policy. Never, it will not restart every time. Okay, just see if we can go and create this kubectl create -y py job. Okay, there is some line number 8, some issues there with all your indentation only. Okay, okay, so make sure that indentation is correct. Okay. The reason for that is it should be metadata. Okay, ensure that CRDs no match kind for job py namespace. Okay, I think it should be app/v1. Okay, namespace is empty, no job kind matches. Okay, I'll just come back on this. I'll give you the correct one. Okay, just give me some time. Okay, so like this you can run your jobs, or you can also run your cron jobs also. You can schedule these jobs and run the jobs for every 15 minutes, 20 minutes, what you wanted to run, right? You can go ahead and run this as well. Okay, you can use the schedule run for every half an hour, right? So you can say run for every half an hour, it will run this job. So you can run a scheduled job as well. Okay, fine. Your deployment still running, all your pods are running, that's fine. Now you can go back and you can check all these things, right? So you want to get any documentation, you can do, or you can also do a cron job which will run for every minute saying hello world, right? You can use this, an image called busybox. Busybox is a small Linux utility where you can go ahead and just check. Even if you want to just run this job once, you can run this job and see if it is getting printed as hello world. kubectl create job, hello, job name is hello, image is busybox, the command is echo hello world. Okay, it will get created and you can go ahead and check this, check the status of this. You should be able to go and see whether it is created or not, right? So you can go and check all those things. Okay, so these are all some of the things. You can go and see all this, all different commands. You can just go through all these different commands and you can go ahead and check all these things. Okay, so you can also do a show label. If you have a label for your pod, it will give you the pod label. Okay, and there is one more. We did yesterday we did install a WordPress, right? We did install a WordPress. You see, I'm trying to install my own image which we already have somewhere else, right? So that also we can go ahead and use it here, right? You can go and get your own image that yesterday that we uploaded, and we can go and use. This is a Node.js application, but you can also use the HTTPD application that we used yesterday. Okay, that we used yesterday, and that since it's a Tomcat, it should be running on 8080, or if it is HTTPD, it will be running on port 80. So you can create this. I will share all these things, and you guys can do that, right? So WordPress is the other one. We will go and try to install this WordPress. So we have a full-blown application which we can we have extracted this. So now go back to how do we upload all these things there? Any idea? Anyone? There is a WinSCP, so you can use the WinSCP to connect to your machine and upload everything there. Let's go and see if we are able to upload it, right? Okay, fine. Now I'm going to do a SFTP, and my host name is going to be this host name, my bootstrapping host name. Okay, my bootstrapping host name or IP, whatever it is. So this is the way. This is the only way that you can go and upload. You don't have a username password. All that we have is only the key. So we'll have to go here, go to advanced, and go to authentication and put your private key here. Of course, I think you may need to give your supports only putty. Okay. putty. Go back here, say okay. Come back here and say EC2 hyphen user and say login. It's trying to connect to the host. Say yes. Then that will do the authentication till starter section. See here, whatever we have there, it's showing here. Now go back to our, what is that? Downloads, and go to this downloads folder. Once you are in downloads folder, you'll be having the K8's demo. Just drag and drop that, you should be able to do it. Okay, you are here. Just go down here and check for your this one. You got your K8's demo. Go into the K8's demo. We have a again K8's demo. Under that you have WordPress, and what you have WordPress service. Sorry, WordPress service and WordPress secrets. Let's start with WordPress secrets, right? So all the secrets that we wanted to pass is here, secrets. So the kind is secret, metadata is give some name, and type is opaque. Opaque means you cannot see the password. And this is the DB password. Name of the password is DB password, and this is encrypted password. So if you want to find out what is this, just go to online and encode it, right? You can encode and find out. Encode online for base 64. Let's go here and put your stuff here. Do an encode. It'll go and decode it. Put it here and go and try to decode. The password is password. That's all. Okay. So this is how we need to add, because it is visible here. We cannot put it as a plain text. Okay. So this is one thing. Next, let's go and see. It is there in the WordPress single deployment. See, this is a bigger one. Yesterday, whatever we did with Docker, the same thing we are doing in Kubernetes. So it's a deployment. Replica is one. And what we are doing, we are selecting the WordPress 4 PHP 7.0, and we are running it in port 80. Environment variables we are passing as WordPress DB password, and that password is taken from the password secrets, right? WordPress secrets. It will take this key and the value will be returned automatically. Then similarly, if you just scroll down, MySQL we are running, again it's the same thing, right? We are using the same password for both. And then we will see how this is getting exposed, right? It has to get exposed. The service that we have created as a kind. So service is used to expose your content to outside world. So we are trying to run on the port 31001, right? On port 31001, we are trying to export this on the container. So now when we try to run this, we should be able to run our WordPress. Okay, now to run, create -f, give a dot. It will run all the YAML files accordingly. See here, it has created the service, secrets, service, and then this one. Now go and say kubectl get service. See here, that's a WordPress service. Okay, that's running on the node port 31001 in 11 seconds, right? Now go and say kubectl get secrets. You have one secret, and that's a WordPress secret, and you can go inside and see. You will only see a encoded stuff, right? And you can also go and check for kubectl get pods. You will see a WordPress deployment is happening there, because it is 2. The replica is only 1. By why it is 2? Because we have both WordPress and MySQL. Both are running there now, right? Both are running there. So if you go back to our go to master, not be running in master, take any node and see if we are able to catch hold of this node. We just need to see if this is getting created. Okay. See here, it's running on 31001. So we asked it to create on 31001. So this is running on the port 31001. If you want, you can run it on a load balancer as well. It is up to you. But you see here, our WordPress has been installed successfully. So now you have both all your. Okay, you can copy this if you need and just give something, right? And install this WordPress. And paste this one. See here, we are in our WordPress. So this is a full-blown application of both front end and back end, and you can see all the details here, right? So it's just a normal Docker, but only the way that how it's getting orchestrated is what we need to take a look at here. Okay, so this is how you will be using some of the basics of Kubernetes. So you can go through more. I'll share some details and I'll share some additional videos which are taken for a deep dive Kubernetes session, and you guys can take a look at that as well. Okay, so if you want to do anything in your local, say for example you want to test your deployment in local, then use Minikube. Okay, Minikube is one of the this one that you can use for a local testing, or you can also use this K8 setup, right? You need to start the Docker and make sure you are getting all the kubectl everything in your local, and then you run this YAML for a like this, right? Whether you want one master and two nodes and all those things you can run here, and then you can go ahead and create your cluster. If you don't give a name, it will create a cluster called kind. Otherwise, give a name. Okay, once all everything is done, you should be able to see this. Okay, so this is how your this one works, and there are a lot of steps here. You can try any of this if you need, right? So you want to go with cube spray, you can go with cube spray. All the instructions are given here. Of course, this will not come in the free tier because it needs minimum 2 CPUs. Okay, so you can go with this if you want, or you want to do a managed EKS, you can also do a managed EKS, and you can go and do that also, right? For if you want to use EKS, then you need to download the EKS CTL as well, right? EKS CTL, like your kubectl, to integrate to talk to the EKS cluster, you need EKS CTL. Okay, you can use this to go and create your cluster, right? So these are all some of the steps. And if you want to do the hard way, right, you want to do everything from the scratch, go ahead and do this, right? Go ahead and do this. You create separate machine and go ahead and do all these things, then this will get ready for you. Okay, just like you remember we did a Docker Swarm init and then we joined all those nodes into the master. Similarly, we need to do. Okay, all these setups will take a lot of time. Even the one that I showed you will take at least 30 to 40 minutes, but you need to be very patient enough to go and do this. Okay. Okay. So like that, there are a lot of here you can schedule jobs using the schedule. Runs every 30 minutes, and this will enter into the container. This one, it will run, check all the processes that are running, right? So you can do that, and you have some. We saw something in the metadata as labels and selectors. Labels are key value pairs which are attached to the pods, replication controller or services. They're used as identifying attributes for objects such as pods and replication controller. They can be added to an object at creation time or can be modified at the later time also. Selector is label do not provide uniqueness. In general, we can say many objects can carry the same labels, but label selector is it's a group, it's a core grouping we have in Kubernetes. They can be used to select a certain set of objects. Say when your label app equal to test alone, you give me all the pods, it will give you. Then Kubernetes API currently supports two types of selector: equality-based selector and set-based selector. Equality means they allow you to filter by key and value. So if app equal to test, then that is the only one equality-based, right? Matching object should satisfy the specified label. Set-based means selectors allow a filtering of keys according to set of values, right? You have like set of values you can do, like say for example, you can say environment in dev or prod, right? You can say that also. That is a kind of a set-based selector. Then you remember we talked about namespace, and we were talking about namespace, how to isolate between three environments. I have the same cluster. I'm having this cluster, but I want to run both UAT or both my dev, UAT and prod in the same. Then we will use something called namespace. So namespace provides an additional qualification to all resource names. This is helpful when multiple teams are using the same cluster and there is a potential name collision. So it can be a virtual wall between multiple clusters. So very important thing is your namespace. It will be used to kind of do an inter-pod communication. But only thing is, please be very careful. Your one namespace cannot talk to another namespace. Okay, all the pods within the namespace only can talk. So we did not specify any namespace. What happened, right? So let's see, kubectl get namespace, right? NS needs a namespace. So if we don't specify or don't create any thing, it will get into default. All these namespace are default. Okay, so how do we get all the pods from all these other public system and other things that are running, right? So let's go and say kubectl get pods -a. See here, it's all running in all the, this one it will show -a. If you see, this is what it will give you. Okay, so you can see in our system what is running, the core DNS, which is using that is what DNS controller. Then you also have an HCD manager here that's running, the COPS controller is running, the API server is running, Kube controller manager is running, and the Kube proxies are running, and the Kube scheduler is also running. See, all these are running, the components that we saw, everything is running here. And this is our default namespace. So all that we deployed will go into the default namespace. So anything that we have here, we cannot talk to here, and vice versa, all those things, right? So that's a main advantage of having this Kubernetes, where you can have same cluster and use it for dev, prod, UAT, and all those things. Okay, so you want to create a namespace, you just need to create a kind called namespace, and you can go ahead and do the create namespace. You will get the namespace. You want to get the particular namespace, you want to find the description, you can delete the namespace. It's all up to you. Okay, so using the namespace in the example, you can see how we are using. We created in the previous step, we created a namespace called Elk. Elk is nothing but your logging mechanism in Elasticsearch. So Elk, and then we are saying this particular pod needs to get into this namespace called Elk. That's all. Then we have a node. We saw that, right? A node is a working machine in Kubernetes cluster, which is also known as minions. In the old documentation, you will see this as a minion, but now it is actually a node. They are working units which can be physical, a virtual machine, or a cloud instance. We are having cloud instance. Each node has all the required configuration required to run a pod on it, such as proxy service, kubelet service, along with Docker, which is used to run Docker containers on the pod created on the node, right? So we saw what kubelet service will do. A service can be defined as a logical set of pods. It is defined as an abstraction on the top of the pod, which will provide a single IP for us to access. With service, it is very easy to manage all your load balancing configuration. If you don't create a service, then you will not know how to reach which pod, right? So internally, the kube proxy will take care of talking to different pods, but to expose them externally, we have to use a service. So that's why here, if you see, we have created this service. So these are the services which will expose the pods outside. So if this we have used the port 31001. Here what we have done, we have used the load balancer, which is mapping to 80. 80 is running and is mapped to 30,127 internally, and this is a Kubernetes cluster IP where your Kubernetes is running. That's running on port 443. That's why you remember when we tried to do the kubectl version, it was saying it cannot connect to the local server on 443. That's because we did not create the cluster at that time when we installed our kubectl, right? So that is the service that we are talking about. Okay, there are different types of service we have. Cluster IP, this helps in restricting the service within the cluster. So within the cluster, this cluster IP will take care of communicating within the cluster. Node port, this will expose a service on a static port on a deployed node, just like this, right? So what we had, we just exposed it on the static port 31,001. So you go to any node on 31,001, that application will be running. A cluster IP service to which node port will be route is automatically created. The service can be accessed from outside the cluster using node IP colon node port. That's what we did, right? We took one of the nodes IP colon the node port 31,001. Now, even if you try to go and do another node here, I just took one node. You can go and take another node and put 31,000 and go copy here and 31,001. Just go and say colon 31,001. Okay, see, this is the one that is running. Hello world, right? This is the one that is running now. If you actually go here, the hello world is running in this. Okay, so this way you can go ahead and check your ports. The next we have is load balancer, where you are basically using your, this will work only with cloud. Okay, this will work only with cloud. Without cloud, it will not work. You can only use a node port or a cluster IP. So then what you will do without the cloud, you will create different machines of node with a node port, and then you will create a load balancer machine separately that will have IP that you will map in the DNS name to the this node port, right? That you will do. If it is cloud, all that is taken care for you and you need not do anything. And there is a replication controller. So this is used for making sure that the pod is always in the desired state, and if you are deleting one, it will automatically recreate because it will manage all your pod life cycle, and it will also make sure that the specified number of pods are always running at any point of time. So if you delete one, it will go and create. It has the capability to bring up or bring down the specified number of pod. Okay, so it's best practice to use the replication controller to manage rather than creating a pod again. You want to create 5 pods, don't create 5 pods, create a replication controller saying replicas equal to 5. So this is what it happens, right? So replication controller, say the replica how much you need, 3 replicas, it will run this application, right? It will run this Tomcat as 3 copies of this Tomcat. We have replica set also. Replica set also it's actually a replacement of replication controller. So it does the same thing. Only the difference here is the replication controller supports equality based selector, that is where app equal to something, whereas the replica set supports the set based selector, right? So you can say set based selector, like you can say here, you can say you can match some expression here saying key equal to tier operation in values backend. So you can say this wherever the tier is backend, it will go and put your pod inside that particular node, right? That is what this replication set will do. But mostly both will be doing the same thing, except this, except the selectors equality based or set based. Rest everything is same for both replication controller and replication set. It is recommended to use the newer replication set. And we saw about deployments already. Deployments are upgraded higher version of replication controller. They manage the deployment of replica sets, which is also an upgraded version of replication controller. They have the capability to update the replica set and also capable of rolling back to the previous version. You have a lot of things to do with your deployments, right? Just go back here, you will see deployment, right? You can go and see all this deployment. You can get the deployment. You can set an image. You can go and do a rolling update. Yesterday we saw, right? We can set an image to something else also, and you can do a rollout. You can undo. You can get the status. You can restart. Everything you can do with your deployment. You can also auto scale your deployment to minimum 2 and maximum 10. So it will make sure that 10 is always running. So if you take this now and just see what we can do, let's go and see if we can do something with this, right? So take any deployment that we have. So here we will be having whatever deployment is here, right? Let's go and check. Okay, so we have this Nginx deployment. Let's try to copy this Nginx deployment. Go back down here and see if we can auto scale. Okay, minimum to max 10. So we already have 2. Let's make this one 4 and max as 10, right? Okay, horizontal pod auto scaler has already been auto scaled. So it is just created. So what we can do, just go and get deployment. You will see once is there anything happens to this pod or it gets full, it will automatically get created another, right? So you can go and kind of do the auto scaling as well for that, right? You can do all those things. So there are a lot of things that you can do. You can patch your deployment and you can go ahead and auto scale your deployment. You can do all this. You can scale current replicas to replicas 3. If the deployment is current size is 2, it will make it 3 and all those things, right? So you can go and put all the things here. You can go and see all the things. Similarly for, you can find out the logs of the pod. You want to find any logs, just go and say kubectl and give that pod name, right? So let's see kubectl get pods. We have a WordPress. Let's go and say kubectl logs. Let's go and see if we have kubectl logs, and you need to give a specific pod name there. See, it's printed all the logs that is there in our WordPress. Right? So it is similar to one that we did yesterday, like Docker logs, right? Both are same. See, only thing here, you will never be able to talk directly to the container. You will only be talking through pods. That's all. That's a key difference here. So you can have deployments and you can update the deployment. You can delete the deployment. You can roll back. You can go and delete the deployment. You can do all the things that you wanted to do. And you can also recreate your deployment. You can do a rolling update, right? You can do the rolling update. So rolling update will be just like whatever we did yesterday, right? So deployment, you can have deployments and you can deploy this, and you can go ahead and create your cluster and start testing this. So you can also create a deployment and you can get your deployment. You can check the status of your deployment, and you can also set image from Tomcat to Tomcat 6.0. So it will automatically start putting your this one. So you can go ahead and do all these things. Okay. And there you can also have volumes, how we had for Docker. You can also have volumes, and volume, what will happen, you can have different types of volumes, and the type of the volume defines how the volume is created and its content. Okay, so this actually created through Kubernetes, is not limited to any container. It will be accessed across your containers. Okay, across your containers. So if you go and see, there's a persistent volume. You need to create a persistent volume with a storage 10 GB, for example. Then once you create a persistent volume, you need to claim the volume. You need to say how much you need for your this one, right? So you can go and create your volume, okay, persistent volume, and you can go and see it has capacity, and you can describe this volume, and you can see what is there, and then you need to claim that volume. How much you need? From 10 GB, I need 3 GB for this particular part, right? You can say that. So it will go on, do the claim, and it will keep 7 there, it will keep 3 here. You can use 7 for the rest of the other stuff, right? So those things that you can do a persistent volume claim and persistent volume. So you can do the same thing, right? PVC and PV. And we saw these secrets. Secrets can be defined as Kubernetes objects where you use to store your sensitive information, such as username, password with encryption. There are multiple ways you can do. You can create from text file, or you can create a YAML file. Creating from a text file, in order to create secrets from text file, make sure that you need to store them in a text file and use the following command. You can pass this username, password while you are running this generic Tomcat password from file. It will use this, or you can use this one. That's what we saw, right? You can give username, password. When you give opaque, it will put that as a encoded stuff on the secrets. So these are all some of the things of the basic stuff that you will just need to know. So let me just put a pause here. You guys have any questions here? So a lot of things we talked about. This might be a little bit difficult to digest, but please go back and take a look at the video and also the PPT, and try to create some clusters and see if you are able to create some clusters. Okay, and please make a note of this official documentation page. This is very important, right? You have to go here only if you're planning to write a Kubernetes exam. Then you have to be thorough with in and out of all these things, right? Otherwise you will not be able to kind of get through. Okay, so you can go and check some of the things. Basics are there. You can go and check all those things, right? And they will also give you how getting started guide, how to create your production environment and all those things. There are multiple ways to create, and I will be sharing all the steps that we will be using for setting up our Kubernetes. Okay. Okay. So this is one of the ways. Is that there are many ways to create it. This is one of the way for you to create it. So here, if you use a kind means kind stands for Kubernetes in Docker. So your Kubernetes itself runs as a Docker image, Docker container. Okay. So you can go and do this, but make sure if you are running this, you will need to run your Docker. Docker should be running before you actually do this. Okay. Actually do this, you need to have a Docker created here. Okay, you can use this. And only thing you need to make sure that you are deleting your clusters without fail, because all these are chargeable. I'm using a T2 medium, which is not a free tier. Okay, which is not a free tier. Now, please don't go back to these instances and delete this node. If you delete this node, it will again create the node. Why it is doing that? Go back to the auto scaling. If you see, it would have already created an auto scaling based upon the desired capacity that we have put there, right? So how many master? One master and two nodes in this region and one node in this region, right? So it has put everything here. So if you go and delete that, that will not happen. So it's always best way to delete is through the command. Say delete your cluster. Don't delete your resource directly. If you delete your resource, it's going to be very difficult. I had very hard time finding out this. So please don't do the same mistake, right? Don't do the same mistake. Okay. And if you go back to the Route 53, what we saw, you will see multiple entries that has been put by the Route 53. Again, Route 53 is your DNS server system for your AWS, where it tries to create records and route the traffic to based upon your this one. So go to hosted zones. I already have my domain. Okay, you can see here there are a lot of 3 records has been created. API dev K8s, then API internal. All these are mapping to this particular machines, right? 54, 172.20, 172.20, 58, 53. So all these are all going here only. So this you need to have a domain name Even if it is a private domain name also, it will work. Okay, but sometimes private doesn't work. So just take a look how you can create this, right? Or if you don't want to buy with the $10, $12, go to Freenom and you can get a free domain and you can come and create it here. Okay, that also you can do. Go to Freenom. There's a site called Freenom. Okay, go to Freenom and you should be able to get a free domain. Be able to get a free domain. Okay, so for example, let me check with my name, Chandra Chennai dot say TK, TKML, GB, GL. I believe some three things are free always. Okay, three things are free, like ML, GA, CF, and GQ are free. So you can go and get this for $0 for 1 year. Okay, so you can use this chandrachennai.tk into your Route 53 here. If you are familiar with AWS, you can do that. Okay, so this is how you can go ahead and do it. If you don't want to buy, right? You don't want to buy, this is the best way to do. Okay, fine. Any other questions, guys? Any questions you guys have? Please download all the materials that are there in the drive because that will be removed after a week or so. So you guys will not get the recordings back again. Okay. Okay. And I think that's it. I just wanted to convey. And if you have any doubt or any questions, please ping me in the WhatsApp. I will get it clarified for you. Okay. And my only suggestion is please do hands-on so you are getting used to all these topics that we have done from Git till Kubernetes, right? Otherwise, you will not be able to remember, right? Unless you work it in the full flow, right? You will not be able to kind of think back what we did, right?
Hi Chandra.
Yeah.
Is this the last class in the DevOps?
Yeah. This will be the last session on our DevOps. Okay.
Okay. Can we have, one project real time? Any end-to-end project using that Git, everything, Jenkins,
Yeah, we did
Kubernetes?
that, right? We already did that, right? Till Ansible we did. Only thing you can use a Docker and you can go ahead and do it. So
Oh,
for doing Docker alone, you just let me show you how it has been done. But I have
okay.
shown you till Ansible. Okay, I've shown you still Ansible. You can also create it as Docker, right? But only thing when you are
Oh,
running your Docker, make sure you have a Docker engine running in your either in your local or in some server so that you can put all your files in your GitHub and you can take it from there. Okay, let's see. Just a
oh,
minute. Kubernetes also the same thing. All that you need to do is have your YAML file in your GitHub, and you just need to call that and using SSH move it to the Ansible. Sorry, move it to the master, and from master you can go to execute it. Right? See Docker jobs. So many things are there, right? Docker pipeline. So it's all very straightforward, right? Nothing different in this.
okay, Chandra, I will try then. I will try to reply.
Yeah. Just try that. Let me show you
Sure.
in case you can try that. So the real project that actually we did, right? Just in case if you are not aware, right? So what we did,
Yes.
we went to Git, we studied Git, then we went to Maven, right? Build tool, and then we went to Jenkins. And before that,
Okay.
what we did, we went and integrated Git and Jenkins, correct?
Oh,
So
yes.
whenever we checked in any code, automatically a build job got triggered, and
Yes.
build job is using your Maven. Then after that is over, what we did a deployment to Tomcat, right? We did a deployment to Tomcat. So that is where our full application, the complete war file got deployed to Tomcat, and we were able to access our application. Then what we did, we learned Ansible, and we went back and integrated Ansible with Jenkins. So we were able to kind of install softwares into different nodes using pipeline. Then similarly we will have to do for Docker and K8s, but K8s alone, please make sure you have your cluster ready, right? Without the cluster, you cannot do this. So if you
Okay.
see for Docker, this is what we have done, right? So this is my repository. Okay, so this is what I have done, and these are all the commands that I have done. So I've just did a build on my job, and then I have run this command using 8900 8900 port, and I'm trying to run this in my local. So my Docker should be running at this point when I'm running this job. So this way you can integrate your Docker, but you need to first Dockerize your application. Without that, we cannot do this. Okay.
Okay, Chandra.
Okay, so similarly for Kubernetes also, all the commands that you have, Kubernetes dot kubectl dot create hyphen f, you're giving some hello.yaml, that YAML file should be there in your GitHub. That's all. It should be there in your GitHub, and you should be able to do it. So you can go and see all those things that we have already done it, and you can take those things from there. Okay,
Okay.
you have all your Git and everything is here. So here, see here, we have a Docker. See, this is what we created from Tomcat. Add what you want to add, what to expose, and what to run for Tomcat, right? So we are checking out this Docker file, and we are creating this, and we are deploying it to our Tomcat. Okay, this is my war file. This is my war file. Okay.
Okay,
This is
Chandra.
my war file that is created from the previous one. Then if you see, I have a Docker pipeline. You can go here and see how to run our Docker pipeline as well, right? You can build a war using MV and Maven clean package, and you can do a Docker build, and you can also do a Docker run, right? So all these things are there. You just need to get this into your Jenkins and run it. That's it.
Okay.
So we are not
I will
building a
do.
separate application for this. Already we have a war file. We are building a war file. We are using that to Dockerize our application. Instead of deploying the actual war, we are creating as a containerized application, and we are deploying into Docker. Okay.
Okay. Got it. Got
So
it,
let
Chandra.
me just do one thing. Just save this somewhere. If you are not able to find it, please save this somewhere. I'll just put it in the chat here, so
Okay.
you can check all the references here.
Okay. Can I
It's
fork
a
this
public repository.
main
Yeah.
project? Can I do a fork for this main project and try?
No, you can. What you can do? You go here.
Hmm?
Okay. After you go here, there is a thing called fork, right?
Yeah, yeah. I said, yeah, even
Oh,
I
yeah,
said
yeah,
fork.
yeah. You can fork. Okay, okay. Sorry. Go ahead and
Yeah.
fork it, and you can start making changes in your repository.
Sure, sure.
Okay. You can fork it, and you can do.
Okay, Chandra.
Okay. All right. Any other questions, guys? So if you happen to go for any interview or planning to get some interview, please let me know. You have any questions you want to clarify before the interview, please ping me, and you can call me also. Okay.
Sure, Chandra. Sure.
Okay. All right. Anything else? One more thing. Um, I'll be sharing the link for the feedback. Okay. So please give your feedback about the trainer and the coordinator in the in that Google review for Besant, so that it will be helpful for us to kind of attract more students, and your feedbacks will be taken in a positive way, so that I can make sure I am delivering my stuff more efficient way for the coming future batches. Okay. Okay. All right. So one thing, just keep in mind, let me also show you how to kind of clean up this, right? Whatever we have done here, because you may be kind of losing money if you kind of um, leave this unattended, right? So let's go and see how to delete our cluster. So what we need to do to delete our cluster, make sure this is again exported. Of course, we didn't close our session, so that export will still be there, but still just to be on the safer side, go ahead and set this so that everything will be taken from your S3. Once that is over, then please go ahead and do cops delete cluster, give your cluster name and say yes without fail. Okay, do this, it will start doing all the things, right? It will start deleting your cluster. See, it will start deleting all the resources, so many resources it has created. Okay, internet gateway, volume, VPC, DHCP, subnet, route tables, right? Security groups, so many things it has created. It will try to go ahead and delete everything. Now, once everything is deleted, then you need to go back and delete your bucket that you created and any other dependency that you have created. The role that we have created, if you want, you can keep it. That is, there is no charge to it, but it's up to you whether you want to keep it or delete it, right? So give a minute. Then if you go back and see here, you should see all your instances getting shutting down. See here, all your instances are getting shutting down or terminated, except the bootstrap one that we are in, right? That is created manually by us, not by the system, not through cops. So all the things will get deleted. Keep your account ID so you don't incur charges. Okay, and you can also go back here, no, not here, to the Route 53, and you can kind of refresh and check if anything is removed or not, right? See, all the three are removed. This NS and SOA record will be there by default. If these two name server and service of authority records are not there, your Route 53 will not work. Okay. So that's where we are. It will just get it deleted in few minutes. Let's give it a minute. And only after the cluster is completely removed, please go ahead and remove your bucket, because all the configurations are there in the bucket only. Okay, you can see all these are shutting down and terminated. So it's trying to delete the internet gateway, security group, volumes for each and every machine. Right? So when you're trying, please try to do one master and 2 or 3 nodes, not 5 or 6 and all, right? Okay, so we are totally done. Everything is gone, and you can come out of this machine and go ahead and terminate your bootstrapping machine as well. Okay, so we should not incur any charges if you are doing it in your free tier account. For me, it is not a free tier account. Mine is a paid account. Okay, so I've been using this account for more than 6-7 years now. Okay, fine. So this will shut down and terminate. Okay, this way we are all good. Just go back to your buckets. Since we created the bucket manually, the only way to do is go and empty this bucket first. Okay, no objects are found, so they're already removed. Just remove the bucket above. Go delete the bucket, and while deleting the bucket, you have to give the name of the bucket, copy from the top and give it the exact name, otherwise it will not work. Okay, your bucket is also deleted. We don't have any S3 buckets, right? So the too much charge will be paying only for the bucket. Okay, right. So if you want, you can download WinSCP, which will basically allow you to transfer files from a remote server to local server, local to remote, right? Local to remote. Okay, fine. Any other questions you guys have? I'll upload this video once it is available, and then you guys can take a look. And if you have any questions, just come back. Please download all the materials. That's very important. If you miss something, then I will not be having it, except some certain things. I will not be having all the recordings at least. So please go ahead and download everything. Okay. So all the best, and I hope you all seeing in some other class. maybe AWS or some other class, Terraform, right? If I happen to meet you, we'll meet there. If not, have a great future. And also, please let me know if you are getting any job on this or you have any queries on this. If you are working in DevOps, you have any queries also, please let me know. I will try to help my best. Okay. Any questions, guys? Anyone?
Sure, Chandra. Thanks for
Yeah.
wishing.
Okay. Yeah. Thanks, everyone. Thanks, and we'll meet in next class if we happen to meet. Okay. Until then, goodbye.
Thanks,
Yeah.
Chandra.
Thank you. Yeah. Thank you.
Thanks.
Bye. Thank you. Thank you.